Okay, so this is about the Turing machine. This is useful if you're just interested in what the Turing machine is, and this is also very useful if you are studying AQA. What is a Turing machine? So let's have a look at some of these slides, and then I'll draw your attention to this article on our Medium, iCodeWithBen. And this article, it just lists all the things that I'm talking about. It has some of the problems that you might want to try and solve so you really understand it. It explains what the Turing machine is again, what transitions are, and then gives you an exercise in which you have to fill out a trace table based on a Turing machine. So what is all this? What is that? Well, Turing wanted to understand what problems are computable and which problems are not computable. So he invented this machine with a tape, and on the tape are ones and zeros. So let's just skip forward to it. Like this is the tape here. There are ones and zeros or a hash when there's nothing in there. And then there was a finite number of states, and each state had a transition. And that transition required an input. For example, if you're in S1, S0, and you input a 1 here, you output a hash, and then there's this arrow which either points right or left, so it tells the read head, which is indicated by a star, to go left or right. So there's this tape, exactly like a tape player was back in the day when we had them. And the tape head would read it, and the tape would move along, and it would just read the information going past it. The only difference here a tape isn't like that is that the tape never went backwards and forwards, didn't kind of read backwards and forwards and jump around like that. So what do we need to have a Turing machine? We need to have an infinite tape, which is not possible really with modern day computers, although all modern day computers and programs are based on this idea of a Turing machine, Turing completeness, because they have a finite set number of states. You transition from one state to the other. You have an initial state and an end state. And he hypothesized that there were some problems that could be solved with computers, and there were some that just could not be solved. And the ones that could not be solved were called the halting problem, where you had a problem and you would never be able to get to a state in which you could finish. But problems you could solve would be simple computable things, like being able to add two numbers together and get a result, or the greatest common divisor. And you can see that because you can write computer programs for those, and you give them two inputs and it gives you an output. And that's what the Turing machine was all about. And Turing tried to describe that there are some problems that can be solved with computers and some that cannot. Then we come on to the idea of what a universal Turing machine is. So a universal Turing machine is a machine that can run any other Turing machine on its tape. So it's a little bit like having a general purpose computer capable of running any software like word processors or web browsers. Like you think of your computer you run on, you've got Word on there, you've got Excel, you've got games and things, and it's like a machine that can run another machine, or a program. Also, you can think of it like a librarian, and all the books in the librarian are sets of instructions for a Turing machine, and with tasks in it they need to perform. And the librarian could take any book and follow those instructions. So yeah, that is what a universal Turing machine is, a machine that can run any other Turing machine on its tape. So now we get on to what a Turing machine actually looks like. So as I said, it's got a finite number of states, 1, 2, 3, 4, 5, 6 states. It's got a halt state, S6, which you can tell because it's got a double circle. Between each state, there are transitions. So we input 1, output hash, and then there's an arrow which points right, and sometimes it points left. That means if you look at this tape down the bottom, where the star is where the head is reading. And if the arrow points to the right after you've done the input and replaced that with the output, so if we did start at S0 and we input 1 here, we would output hash, replace the 1 with a hash, and then we would move the head to the right. So we put the star there to indicate that. So that is how you move using the tape to read the instructions, and you move from state to state until you can get to a halt state. So what I want you to do now is to look at these, either pause this slide or look in the link below at the Medium article about Turing machines, and on it you'll find this problem. You'll find this Turing machine, and then you'll find this problem. And what you need to do is you need to start in state S3, and you need to read this tape, and you need to complete the other lines in the tape below. So for example, if I was going to write out the line beneath that, how the tape would look beneath that, if we carried out the instruction where the head is there at 0 and we're at S3, we'd input 0, we'd output 0, we'd replace it, and then we'd move to the left because the arrow is pointing to the left. And then we would input 1 and we'd output 1, and we'd still be in S4, state S4, and we'd move to the left. So you need to read this ticker tape here, this Turing machine tape, and then follow this state diagram up here, this Turing machine, see if you can complete all the lines in there. And this is the solution, which is also in the article, but don't look at it yet, because that's cheating, and have a go at that. And then you'll get a good idea of how a Turing machine is meant to work, and that will help you if you are doing the exam for AQA. And here's one more slide about what this halting problem is. As I said, there are some problems that cannot be solved by computers. So we input X, input program P. The halting problem or the decided problem decides whether or not this problem can be solved. If it cannot, then it won't halt. We won't get to an end state, and that proves that that this particular halting problem could not exist. And it dispelled the belief, upheld this point that the only limits on algorithms were existing hardware, size, memory, speed of processors. So, and what Turing was trying to say was it wasn't the lack of technology, it was the fact that there are just some problems that are not computable. So again, go to the link below and look at this article and read through it to refresh yourself about what I've just said, and then try and complete this table, and that will help you understand how to navigate your way through a Turing machine and read a tape. Thank you.